Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 4, Moving Charges and Magnetism. Today is not a problem solving session, problem questionnaire session. That is, 7 questions will be showered in this session, and in next session we will solve the solution for this question. Let's move to question number 1. Two toroids 1 and 2 have total number of turns 200 and 100 respectively, with average radii 40 centimeter and 20 centimeter. If they carry same current, in the ratio of the magnetic field along the two loop is dash. A option 1:1. B option 4:1. C option 2:1. Last option 1:2. You should know the formula for B for toroid. By knowing the formula with respect to the radii, you are able to find the solution for this question. Let's move to question number 2. A cylindrical conductor of radius capital R is carrying a constant current. The plot of the magnitude of the magnetic field B with the distance D from the center of conductor is represented by the figure dash. That is, option A, B, C, D as 4 graph is given. That is B versus D graph. For radius or capital R is the radius of the cylindrical conductor. By knowing the relationship between B with respect to center and the distance, you are able to find the solution for this question. Let's move to question number 3. A long wire carrying a steady current is bent into a circular loop of 1 turn. The magnetic field at the center of loop is B. It is then bent into a circular coil of N turns. The magnetic field at the center of this coil of N turns will be dash. Option A, NB. B option, N square B. C option, 2NB. D option 2N square B. Here you should know the relationship between B and I with respect to distance or length. Then you are able to find the solution for this question. Let's move to question number 4. Two similar coils of radius R are lying concentrically with their planes at right angles to each other. The current flowing in them are I and 2I. The resultant magnetic field induction at the center will be dash. A, √5 mu naught I by 2R. B, 3 mu naught I by 2R. C, mu naught I by 2R. D, mu naught I by 2R. Here you should know the relationship between magnetic field for the coil in the carrying current. And your resultant magnetic field for these two you should know. Then you are able to find the solution for this. Let's move to question number 5. A straight wire of diameter 0.5 millimeter carrying a current of 1 ampere is replaced by another wire of 1 millimeter diameter carrying same current. The strength of the magnetic field far away from is dash. A, twice the earlier value, same as the earlier value. C, 1/2 of the earlier value. D, 1/4 of the earlier value. Here you should know the relationship between magnetic field B and the diameter or distance. By knowing the formula, you are able to solve this question. Let's move to question number 6. An electron is moving in a circular path under the influence of a transverse magnetic field of 3.57 into 10 power minus 2 Tesla. If the value of E by M is 1.76 into 10 power 11 coulomb per kilogram, the frequency of revolution of the electron is dash. A, 1 GHz. What is it? Gigahertz. B, 100 megahertz. C, 62.8 megahertz. D, 6.28 megahertz. Here you should know the relationship between the frequency, magnetic field, and then E by M value or E value M value, that is cyclotron formula. By knowing the formula, you are able to find the solution for this. Let's move to last question. A beam of electron is moving with constant velocity in a region having simultaneous perpendicular electric and magnetic field of strength 20 volt per meter and 0.5 Tesla at right angles to the direction of motion of the electron. Then the velocity of electrons must be dash. A, 8 meter per second. B, 20 meter per second. C, 40 meter per second. D, 1/40 meter per second. Here you should know the relationship between velocity, its field strength, and by knowing the value, you are able to find the solution for this question. Thank you, students. In next session, we will see how to solve this question. Thank you.